Welcome back everybody to the last video in this series of 3 videos looking at significant figures and basic operations with them, looking at addition and subtraction this time around. Once again, looking at the general rule for addition and subtraction here, the answer to any addition or subtraction problem should be rounded so that the final digit is in the same place as the leftmost uncertain digit. Just like before, we're going to come back to this rule in just a second after we kind of get some pre-thoughts out of the way to kind of talk about what this means right here. And same thing as before, I'm going to pose to you a kind of scenario here that we're going to frame our kind of mindset around. So if you take a road trip, starting from your house at this 0 point, and it's going to be about 3,000 kilometers until the end of your trip. About 3,000 kilometers. If you kind of think about this in terms of the annoying younger sibling that is just constantly asking if we're there yet or if we're getting close yet in this trip, it starts to kind of get an idea of why this addition and subtraction works the way it does. All right, so let's say that you go, for argument's sake, 5 kilometers down the road. And they ask you, are we close yet? Are we there yet? Is 5 kilometers worth of travel going to make any sort of dent in 3,000 kilometer estimation of this trip? Meaning if you got 5 kilometers closer to something that was about 3,000 kilometers, rounded to that nearest 1,000 kilometer there, would you really be any closer than you were before? Physically, yes, but in terms of this estimation, if we took 3,000 kilometers and subtracted 5 kilometers from this, if this was math class and we were working with exact numbers, 3,000 minus 5 would still be, would be 2,995. But if we took about 3,000 and subtracted 5 from that number, in terms of estimations and in terms of measurements, this is still going to be about 3,000. So again, we have the science way and we have the math way. We're looking more at this estimation and where our rounding took place, more so than we are trying to do exact measurement, exact number calculations here. Another way that you could think about this, if the distance is kind of throwing you off, one of those kind of contests I know that came up at the library a lot, in our library, public libraries, they put a jar in front of you and ask you to estimate the number of coins, jelly beans, something inside of this jar. Let's say, again, for argument's sake, Mr. Fagan says, this is about 3,000 jelly beans. I'm not saying that it's exactly 3,000 jelly beans, but I'm going to say, with my estimation being in this thousands place here, that I think it's going to be roughly 3,000 jelly beans. If the librarian comes over and adds 5 more jelly beans into this jar, does that really change the fact that I thought that there was about 3,000 rounded to the nearest 1,000? Would 3,000 about plus 5 make any change in the fact that I rounded to this thousands place initially? Probably not. So 3,000 about plus 5 is still going to be about 3,000 still. And it all has to do with where we made our estimations. In this example here, we had an estimation in the thousands place for the 3,000 and an estimation in the ones place for this 5. If we think about this in terms of actual numbers then, the mathematical approach to it. First, and said that this turned out to be 3,005. Now if we take into account where our estimations took place, I rounded initially in the 3,000 number to the thousands place and rounded in this 5 number here to the ones place. If I round to something, I have no idea what is coming after that. That's where my estimation took place. So if I rounded here to the thousands place, I don't have any information about what comes after that. If I round here to the ones place, I don't have any information about what comes after that. So where we've made our estimations is kind of where we need to cut off our number. So we could think about how we would have to cut this number off and round if there's anything after the ones place based off of this estimation. And we would also have to cut off and round anything that came after the thousands place based off of this estimation here. So if I took this number and rounded to the ones place and then rounded to the thousands place, this would give me 3,000. But because rounding more than once in any situation throws your data off even more, we're only going to round once. And since we're going to get rid of this stuff in the ones place by rounding to the thousands place, we are only going to round to this thousands number for this calculation, for this estimation. In this case, it's not going to make much of a difference, but there are some cases where if we have 2 places that are next to each other, this can make a difference. So we only ever want to round once in our calculations. Let's take a look at some kind of like step-by-step, if you're somebody who is a little bit better with algorithms or kind of step-by-step ways of looking at these types of things. Step-by-step kind of way to look at these addition and subtraction rules. Similar to what I just did, you're going to line up the numbers and keep the decimal points on top of each other. So for 3,000, we would have an imaginary decimal point there, and for 5, same thing, imaginary decimal point there. We don't want to include those decimal points because they don't actually exist, but we want to think that they're there. So we line our numbers up. We're going to go ahead and perform this calculation after indicating where we estimated. So I'm going to draw a line under the uncertain digits in each number where we did our estimations. I estimated at the thousand spot, so I'm going to underline the 3 here, and I estimated at the 1, so I'm going to underline the 5. 3,000 plus 5, we perform the math, is 3,005. And I'm going to carry these underlines down to show where my estimations took place. We rounded at the thousands and we rounded at the ones in these numbers here. And then for the last part here, we're going to round off at that leftmost uncertain digit or the leftmost spot that we did our rounding in our initial measurements. So because I rounded here at the 3,000s place, the thousands place, excuse me, it doesn't matter what comes after that because everything is going to get rounded from that point. So I don't care that there's a 5 down here all the way at the end because it has very, very little impact on what's in the thousands place, which is where the estimation took place. So this number here would round to 3,000 in our significant figure calculation. All right, same thing as before. We're going to go ahead and take a couple more examples here. Pause here right now if you want to try these on your own first. For this first example, I have this written out horizontally here. I'm going to go ahead and rewrite this because I don't want to be lazy. I want to make sure that I get this correct. So 53.691 grams for our unit plus 3.47 grams. In this first number here, my estimation took place all the way at the end because that's the number that I would have pulled off and rounded on the scale. And same kind of deal. Our estimation took place at this hundredths place here, so I'm going to underline that value. I'm going to perform the calculation. When I add these numbers up together, I'm going to get 57.161. And then I'm going to carry down those estimations. We estimated at the hundredths and the thousandths point. So anything that comes to the right of these estimated digits doesn't matter, doesn't have any bearing on those important numbers. So we're going to round everything else off. Our 6 here is what comes most to the left, so anything that comes to the right after that is going to be rounded. And 57.16 is going to be rounded to 57.16 grams. Got to remember the unit. Same thing for the second one here. Rewrite my problem vertically so it's a little bit easier to see. 107.1614, this time feet, plus 3.21 feet we're going to go ahead and underline where our estimations took place. In the first number, we estimated at the 10,000 spot. That's where our rounding happened. In the second number here, we estimated and rounded at the hundreds place, so we're going to underline that. Perform the calculation. When we add these together, this is going to be 110.3714, where we estimated at the 7 and we estimated at the 4. The 7 is the leftmost, and anything that comes after that 7 then does not have a bearing on what this would be to this original estimation that we made, so we're going to round everything. So the 1 here is going to round to the 7, this will round down, and so our number here for our final answer would be 110.37 feet. And for our last one, same deal. Gonna do 60 liters plus 5.525 liters. Our estimation here took place at the tens place. That's where we rounded based off of the significant figures we have. And our estimation in the second number here happened at the thousands place. Performing the operation, we have 65.525. Carrying down our estimations. Since we rounded in the tens place, it doesn't matter that we rounded in the thousands place. So we're rounding everything that comes after the tens place. 5 is going to round up, which makes this answer 70 liters. Now this works the same for subtraction as well. We didn't do a subtraction problem here, but subtraction should work the same way, and then we will have some subtraction problems that we'll do in class. Once again, I hope this helps, guys. If you have any additional questions, please talk to me outside of class time. Feel free to shoot me an email or talk to me at any point if you need additional help. Again, we don't have a lot of time to talk about this in class as we have a lot of material to cover for this course. Thank you. Have a nice night.